Okay, so let's pick up. Since I wasn't here on Friday, the schedule actually works out. We're going to be finishing up Unit 4 today and Wednesday. And this coming Friday, we'll be looking at test on Unit 4. So we got some camera problems there in Schwamigan. Here, just a second. Maybe I might be able to take control of it for you. Oh, it doesn't look like it's going to let me.
Can you see us?
I'm looking at a wall right now. I'm looking at a wall, and there we go. Now I can see you. That's better. So you just had to zoom out. There we go.
Okay.
Thanks. Okay, so now we're set. Okay. Sorry about being gone on Friday. Like I said, it actually works out better with our schedule anyway. It puts our test this coming Friday. Today we're going to finish up some of the graphing side of it and data graphs. Wednesday we're going to talk about variation and relationship between variables. And the test will be Friday. So that means next week we start our unit on statistics. And we'll spend about 4 or 5 classes on statistics. Then it'll be time for our final test. So let's go ahead and start on our new material here. We left off last Wednesday. We were writing equations from given information. So if I gave you the information that an equation goes, or a line goes through the points 4, 7, and 8, 10, we could find the equation of that line. And to do it, we first found the slope. And to do that, we use that slope formula, m equals, we had points 1 and 2, so it was y2 minus y1 over x2 minus x1. So for these 2 points, we'd find the slope. What's y2 going to be? Point 2, y coordinate is 10. Then minus, what's y1 going to be? Point 1, y coordinate is 7. So then on bottom, x2, point 2, x coordinate is 8, minus what's x1 going to be? Point 1, x coordinate is 4. So we subtract 10 minus 7 gives us 3. 8 minus 4 is 4. We got a slope of 3/4. So that told us the equation starts out as y equals 3/4 times x. Remember, it's slope times x plus that y-intercept of b. So we have to figure out what b is. And to do that, we picked either one of these 2 points. I'm just going to use the 4, 7. So which number goes in for y? The y coordinate is 7. 3/4 times x would be the 4. So now we've got 3/4 times 4, which is just 3. So 7 equals 3 plus b. And we solve for b by subtracting 3. So 4 equals b. So we bring that back up and replace b in this original form of the equation with 4. So y equals 3/4 x plus, oops, not plus b anymore, it's plus 4. Well, today what we're going to do is we're going to do something very similar to that, only we're going to explore the ideas of parallel and perpendicular. So let's look at parallel lines and how they relate on a graph. let's say I have a line y equals 2/3 x plus 1. Where is that going to start on my graph? The y-intercept's positive 1, right? So we got positive 1. From that point, our slope tells us what to do. The slope is the number that multiplies x, the 2/3. So that's telling us that from that point, we go up 2 over 3. And there's our line. Now, if I want to graph a line that is parallel to that, but I want it to start up here at 4 on the y-axis. Well, parallel, if I just look at it, just draw it in quick. One, I know I can tell here that the y-intercept is 4. And looking at them being parallel, I can tell the slopes must be the same. So the parallel line to that original line must be y equals still 2/3 x, because it has to have the same slope, but now it starts out at positive 4, so plus 4. So parallel lines have the same slope. A little bit trickier is perpendicular. Remember, perpendicular must form a right angle. So I'm going to take a look at this line right here. I'm going to draw in the triangle. I'm going to erase these little marks here so I don't confuse us. I'm going to draw in this slope triangle here. This has, of course, it's a right triangle. This is a rise of 2 and a run of 3. The line that's perpendicular to that is going to come in. I want to go through that point just to make this easier on myself. It's going to come in something like this. Now, the first thing we can tell is that this line, the blue line that we started with, had a positive slope. The perpendicular has to have a negative slope. In math, that's what we refer to as opposites. Remember we talked about adding the opposite when we subtracted? Adding the opposite of a positive was a negative, and the opposite of a negative was a positive. So it must be opposite. Well, the steepness of that line is not going to be the same. Again, to form a right angle here, or over here, we have to look at that slope triangle. We have the angle here formed by that slope triangle. This angle here has to be its complement. They have to add up to 90 degrees. Well, we haven't had formal geometry in this class, but I'm assuming some of you guys have had some exposure to geometry. If I look at that right triangle, in any right triangle, the complement of this angle here is the other non-right angle in that triangle. Those two angles must add up to 90 degrees. So in order to create a right angle here, the angle that I need to have here is just this one from that slope triangle. So what I end up doing is drawing in that slope triangle like this, putting this angle in that spot now. And what happens when I do that is this side that was 3 is now here. This side that was 2 is now here. That slope is not only negative, but it's now 3 over 2. The rise and run have switched places. Switching the rise and run, or the numerator and denominator, is what we call the reciprocal. So if we have perpendicular lines, their slopes are opposite reciprocals. So let's take a look at this. If I have an equation, y equals negative 3/4 x plus 7. What is the slope of a line that would be parallel to that? Well, first of all, what's the slope of this line? Well, the slope of this line is the negative 3/4. That's the number that multiplies x. The slope of a line parallel to that is the same, negative 3/4. Slope of a line perpendicular to that is going to be the opposite reciprocal. Since this one's negative, this will be positive. 3/4 becomes 4/3. So again here, y equals 2x minus 4. The slope of this line is 2, or it can be thought of as 2/1. Slope of a line parallel is going to be the same slope, just 2. Slope of a line perpendicular to it, well, it's going to be the opposite. So since this one's positive, this one's going to be negative. 2/1, the reciprocal is going to be 1/2. So negative 1/2. Now, it might not always be quite that simple. We might have 2x minus 5y equals 10. And we have to solve that to get it into our graphing form, our y equals form. So first thing we'd have to do is subtract the 2x. Don't forget the negative on that 5y. It's negative 5y equals 10 minus 2x. And then we have to divide by the negative 5. So y equals 10 divided by negative 5 is negative 2. Negative 2x divided by negative 5. Well, negative divided by negative is a positive. Take the coefficient of the x, which is 2 over the 5, is 2/5 x. So the slope of a line that would be parallel, the slope of this line is just 2/5. So the slope of line parallel would be just 2/5. Slope of line perpendicular would be the opposite reciprocal. So this one's positive, the opposite would be negative. 2/5, the reciprocal would be 5/2. So if I give you a pair of equations, you should be able to tell me if they are parallel, perpendicular, or neither. So looking at these two equations here, are they parallel, perpendicular, or neither? Well, it's tempting to say perpendicular because we've got 2/3 and 3/2. But they're both positive. To be perpendicular, they have to be not just reciprocals, but opposite reciprocals. One positive and one negative. So that is neither. We have y equals 4/3 x plus 7 and y equals negative 4/3 x minus 2. Parallel, perpendicular, or neither? Well, I have opposites now. I have 4/3. Unfortunately, to be parallel, they both have to be the same sign. So one's positive, one's negative. They can't be parallel. And to be perpendicular, they can't just be opposites. They have to be opposite reciprocals. So I have a positive and a negative, but they're both 4/3. So that is also neither. Y equals 1/2 x minus 3, and y equals 7 plus 1/2 x. For these, the slope up here is 1/2. The slope down here is 1/2. Since they're the same, they are parallel. And my final pair, y equals 2/3 x plus 5, and y equals 2 minus 3/2x. Well, the slope here is 2/3. This one is a negative 3/2. They are opposite reciprocals, so those are perpendicular. So it can come down to being asked to write the equation of a line we're going to assume that opening portion of the question for the next several examples. Find the equation of a line parallel to y equals 2/5 x minus 3 and through the point 10, 1. Oops. Let's do 10, 7. Make that a little easier. So the first thing we need, the only thing we need out of this equation here is the slope. The slope is 2/5. That's all we need that equation for. The rest of it is just garbage. Now we know that we're looking for a parallel. The parallel will have the same slope. So we're going to still be 2/5. So we'll start our equation out. Y equals 2/5, the slope times x, plus whatever my y-intercept of b becomes. Now we can use the point that we know the line has to go through, putting 7 in for y. The 10 has to go for x. And we solve. Well, 2/5 times 10 is 4. And we subtract 4 to get b by itself. 3 equals b. So we come back up here, we replace b here with 3. So that gives us that our equation is y equals 2/5 x plus 3. So I might find the equation of the line parallel to y equals negative 2x minus 1 and through the point 2, negative 1. So again, the only thing we want out of this equation is its slope. The slope there is a negative 2. For a parallel, the slope will still be negative 2. So we start out our equation. Y equals negative 2x plus b. We use our through point. So y would be the negative 1. X would be the positive 2 plus b. Negative 2 times 2 is a negative 4. To solve for b, we're going to just add the 4. It's minus 4, so we're going to add 4. So we get that 3 equals b. So again, we come up here to this generic equation we started. We replace b there with 3. So that gives us not just y equals negative 2x plus b, but y equals negative 2x plus 3. We might be asked to find the equation of the line perpendicular to y equals 2/3 x minus 5 and through the point 6, 1. So again, we look at this equation, and the only thing we want out of there is the slope. The slope is 2/3. Now this time we're not looking for the parallel, we're looking for a perpendicular. So the slope of the perpendicular will be opposite. This one's positive, so this will be negative. And reciprocal. 2 over 3 will become 3 over 2. So that's the slope we need. So we start out our equation y equals negative 3 over 2 times x plus b. And we use our through point, 6, 1. 1 goes in for y. 6 goes in for x. Negative 3 over 2 times 6 is a negative 9. And we will add 9 to get rid of a negative 9. So 10 equals b. So again, we go up to this equation here and replace b with 10. So y equals negative 3 over 2x. Instead of just plus b, it's plus 10. So very similar to what we did last week, only we have to pick the slope out of the equation. So let's do one more perpendicular here. So I want the equation of a line perpendicular to y equals negative 2x plus 3. And through the point 4, 1. So again, all we want out of here is the slope. The slope of that is a negative 2. You might think of it as a negative 2 over 1. For the perpendicular, it's going to be the opposite, so that's negative. This will be positive. Reciprocal, 2 over 1 becomes 1 over 2. So my generic equation starts out y equals, the slope is going to be 1/2 times x plus that y-intercept. So put in b. Using our through point of 4, 1. Y equals 1. 1/2 times x is going to be the 4 plus b. So now we have to combine 1/2 times 4 gives me 2. So 1 equals 2 plus b. And I have to subtract 2. So negative 1 equals b. So I go back up here. I'm replacing b here with negative 1. So that equation, instead of y equals 1/2 x plus b, is 1/2 x minus 1. Any questions there? Okay. Well, our next step, we want to talk, shifting gears a little bit, I want to talk a little bit about data graphs. We've talked about algebraic graphs and graphing things, you know, y and x and stuff like that, x and y. Let's talk about data graphs. So far, what we've talked about with these graphs having the y and x axes, the x being down here and the y, of course, up here, forms what we call a scatter plot. In real life, the scatter plot does not necessarily throw points on a perfectly straight line or on a perfect curve even, like we've been doing so far in this class. A lot of times you'll graph points and they might be kind of close to a line, but spread out like this. Each point, just like the points on our graph, represent two numbers. It represents a number down here on the x-axis and a number down here on the y-axis. So far, we've said that the x-axis is what we call the independent axis. and the y is called the dependent axis. We stated that the value of this y-axis depends on what the value is on the x-axis. Well, that makes it sound like it's totally determined by that. And that's not true. The value of this dependent variable, or the y-axis, is influenced by the value of the x-coordinate of that point. Not totally determined by, it can vary slightly from that. Our next unit is being on statistics. If we had more time on statistics, like about 7 or 8 weeks more time, we would get to the point where we would actually talk about finding the equation of the line that goes through those points. It gives us the best fit, or the closest line. It's called linear regression. Well, finding the equation of that line that goes through the middle of those points, or the best line going through those points, means nothing if we don't know how good it is. There's something called correlation that tells us just how close it is. The closer that correlation is to 100, or to 1 or 100%, the closer those points are to the line. The closer that correlation is to 0, the further they are away from it. Now, we're not going to talk anymore about correlation here because, like I said, we don't have time to get that deep into statistics. But just so you know, the points that you usually work with do not fall perfectly on that straight line. They usually vary from it slightly. So to be able to use that line, you have to have more information than just the equation. Okay, we have a few other types of graphs for data that we want to talk about. One of them is for if we're dealing with, rather than numbers, categories. Let's say the hospital has patients in there right now. The ER has 12 patients. The intensive care unit has 24, and for lack of a better word, I'm just going to put standard recovery has 84. So this is the type of patient here, and this is what we would call the frequency. In the statistics section, we'll talk a little bit more about that frequency and things we would do with it. But for right now, we want to talk about the table, which is what we have here, and different ways of displaying it. Now, since there's only 3 different categories here, if I asked you which classification or which area has the most patients in it, you can pretty quickly look through 3 numbers and find the largest number is the 84 in the recovery unit. But if I had broken it down more to cardiac care and OB and the maternity ward, stuff like that, you could end up with dozens of categories there. It'd be really tough to look at them and pick out which one is the largest. Or if I actually compare which has more of the ICU or the ER. Again, with only 2 numbers, we can look at them really quickly and see we've got 24 and 12. The ICU has more patients. But again, if we had more categories, it might be more difficult to find them and pick them out. So what we do is you display them in something called a bar graph. A bar graph can be done in one of 2 ways. This is what we call a vertical bar graph here, because the bars are going to be vertical. I'm going to put ER on bottom, ICU, and recovery. So you can see my categories here going on the bottom axis. Up the side, then, I have to number this in such a way that the largest number still fits on the axis. So I'm going to go 10, 20, 30, 40, 50, 60, 70, 80, and 90. So I've numbered up at least to my smallest number, and of course this you may sure go a little bit past. So for ER, there's 12 people. It's about here. There's ER. ICU, there's 24 people. That'd be about here. And recovery, 84 is going to be somewhere in here. Like that. Now this is called a vertical bar graph because the bars go vertically. It implies that there's something called a horizontal bar graph. And that would be a graph like this where you'd put ER, ICU, recovery on the side here, and the bars would go like this. You'd have the numbered scale across the bottom down here. Either way, what you can see here is very quickly, if I ask you which area has the most patients in, I can very quickly pick out that's the tallest bar, that's the recovery unit. Or which area has the fewest patients in it. This is the shortest bar, that's the ER. Or if I wanted you to compare two of them, again, I could very quickly find their bars and compare their height. So a graph is really good for finding the extremes, smallest, largest. Get that written down. Smallest and largest. And it's also good for comparing. What it's not good for, if I were to ask you how many people in the recovery room, well, you find that, you trace it over. Was that 83, 84, 85? What is it? It's not good for finding exact numbers. So while the graph is good for comparing, finding the smallest or largest, or comparing to, if you want exact numbers, that's where it's best to go back to a table. Now, something with bar graphs that I should make you aware of. Let's say I have a list of, I'm just going to list 3 hospitals, A, B, and C. And before I fill in their frequencies, I'm going to construct the graph. Now I'm going to list number of patients. So hospital A looks something like this. Hospital B, something like that. And hospital C, pretend those bars go straight up and down. Looks something like that. Well, looking at this, it appears as though hospital A has twice as many patients as B. And the hospital C has 3 times as many patients as B. But in reality, the numbers here, hospital A is 462, B is 423, and C is 508. Yes, hospitals A and B have more, or A and C have more patients than hospital B, but not double or triple. The reason it looks like it here is because of this symbol on the axis, which means we skipped several numbers. Now, there's reasons why we would do that. It's much easier to see these now. If I compared that to a graph done without doing it that way, where I'd have to start numbering at 0. So A would go up like that. B would go up like this. And C. So from that graph, I can still see that C is the largest and B is the smallest, but I see they're all really fairly close in size, not this huge difference. But having this break in here allows us to get a little bit of an idea. I still can't tell exactly how many patients are in hospital B, but I can tell it's close to 425, close to halfway. Whereas over here, if I trace that over, that could be anywhere from 410 to 430 or 440. Could be a huge range that I don't know exactly where that's going to be. The moral of the story is there are a lot of things you can do to make the data more clear, but sometimes trying to make it more clear, like this, you can make it confusing at a glance. So for you guys, when you're reading a graph, be very careful that you know what the scale up the side is and what everything represents. If we had more time, and maybe if we get some time in the next unit, we might come back and talk more about these deceptive graphs, misleading graphs. But there's a lot of things that can be done in statistics that can be misleading. And in representing data that can be misleading, so you gotta be careful of it. Okay, the next type of graph we want to look at is a circle graph or a pie chart. The difference between a circle graph and a pie chart is simply the type of data they represent. A circle graph is representing different categories of numbers, and a pie chart is representing different categories, period. Let's take a look here at the average student in college, their expenses and what each costs. So let's look at tuition. Might be $5,200 a year. Books, believe it or not, this is probably a lowball offer, a lowball number, about $900 a year. And supplies, let's go $300 a year. So if I want to make a circle graph or a pie chart of this, what I'm looking at, what I usually graph on those is percents. So to find the percent, I would have to find the total here. I would add those all up. That's 6,400. Then I'd find the percent that each of those is. So 5,200 over 6,400 is blank over 100. If I cross multiply and divide, I get 81.25%. If I did the 900, I'm going to take a shortcut and just punch these in because we're running low on time. 14.06%. Now you'll notice that number had to be rounded because it's 14.0625. Had to round it off. Then the 300, it's going to be 0.469%, or 4.69%, we're going to call that. Again, you see that had to be rounded. If I add these up, they should come out to 100%. But because I had to round them, they might come out to like 99.8 or 100.2 or something like that. They should come out really close to 100. So when we go to graph, we know that on the circle, half of a circle is about 50%. Quarter of a circle is about 25%. Now, 30 years ago or so, they would have figured out, well, what percentage of 360 degrees, or find 81.25% of 360 degrees to get the angle and use your protractor to mark that out. Now we have technology. I mean, almost every computer has Excel on it, where you can punch in the numbers and spit out this graph really quickly. So we're not worried about being that precise with it. We're just worried about knowing the structure of the graph. So 81.25 is a little bit more than 75%. So 75% would be, this right here, this whole wedge. So I'm going to do 75, the 81.25%, a little bit bigger than that. So something like that. That is tuition. So get rid of those because they're not really there. They're just guidelines. And the rest of it looks like this is a little bit, almost 3 times as much. So I'm going to cut it like that. This is supplies and books. Okay, the final type of graph I'm going to talk about here in the last 2 minutes. All the graphs we've talked about so far are just a single snapshot in time at one point in time comparing different values. This graph compares one value at different points in time. It's called a time series graph. And a time series graph is usually a line graph. At least that's the most common one we look at. Let's look at 4 different years. Let's do 2000, 2005, 2010, and 2015. And let's look at the cost of tuition. So let's say in 2000 it was $98 a credit. In 2005 it was $113. In 2010, let's say it took a big jump up to $154. And in 2015, a little bit of increase in state aids, $149. In a time series graph or a line graph, time always goes on bottom. So 2000, 2005, 2010, and 2015. Numbering up the side, we still have to account for all those numbers. So let's see, let's do 20, 40, 60, 80. Now as you see, I don't have to label every mark as long as each mark has to stand for the same amount. So I can figure out, even though they're not labeled, how much they really stand for. So 140, 160, and that's high enough. So 2000, it was $98, would be right about there. 2005 was 113, it would be somewhere in here. 2010, 154 would be up here. And 2015, 149. As I connect the dots here, mine's a little bit spread out, but what you can see here really quickly is where it was rising. Here, the price was increasing. Here, the price was decreasing because that line's sloping slightly down. The other thing you can find here is where it was increasing the fastest. The line is the steepest here, so that's where it was increasing the fastest. I am out of time, so let me give you some homework. Homework's going to be twofold today. It's going to be out of the book, page 326 through 329, or through 330, sorry. That goes over these data graphs, that's 1 through 10. And then on Blackboard, you scroll down in that course information where all the course recordings are. You scroll down here on 419, 421. There is a graph. It says quadratic, parallel, and perpendicular. If you open that up, it's writing equations for lines for the parallel and perpendicular. So practice on those. On Wednesday, we will talk about variation. And Friday will be our test. Okay, that's about it. So you guys have a great day.